And I believe when we calculated the regression line, it was this line y equals 0.433883 plus 0.64652x. And I'm going to attempt to sketch this. I sketched the scatter plot. I'm going to attempt to put the point in as best as possible. Did you know that this regression line always goes through the mean? The mean x and the mean y as a point? So I think we calculated a ton of stuff when we were doing this before. And I have in my calculator still the y bar is 2.27 and the x bar is 2.84. So to help me make sure that I'm drawing this line correctly, I'm going to actually plot this point, 2.8 and about a half and 2.27. It's going to be somewhere around here. I'm going to kind of circle it because I'm adding this point to it. This is the mean, and this is always part of the regression line. Also, it's got to start at 0.433. So it's all the way down there. That doesn't help me. Okay, so I have a real good estimate of where the regression line should be on there. And definitely goes right through my point x bar, y bar. So the average of x and the average of y. And there's a few things that we're going to calculate with this information. Remember before we were talking about residuals, which was the distance between, let's see, I'll take the last number, between what was predicted, and the line is the predicted value, the point is my actual value. And we calculated the residuals by taking the actual y and taking away the predicted y. And then we went back to this line and we said actually this regression line should have a y hat because that is a predicted value. And we can kind of estimate where the predicted value was. And we summed up all of these and we squared them and we did different things with the residuals. What we're going to talk about is this type of error. We consider this an error here. Technically, it should be a little bit closer to 2.75, looks like. But instead, it's all the way up at 3. So we consider that an error. We consider it like an unexplained error, is how we would say. So maybe we could put this down here. An unexplained deviation or an unexplained error there. And one thing that we want to talk about is if you sum up all of these errors squared. Remember we were talking about the residual, the square of the residuals, and we did a little activity. If you sum up all of them, you get the sum of the squared errors, which we call SSE. And the other thing that I want to look at is something called SST. And what we need is, we need the line for the mean of y. So remember, right here was my x bar, my y bar. This is actually my line of my mean. of my y values. And this is the mean of y, the line. If you calculate from the point all the way down to where the mean of y would be, that is considered the sum of the squares total. This is y value, take away the mean of y. And if I put it at the bottom, I might have enough room. If you add up the y minus the mean of y, squared, it's called the sum of squares total, or SST. And we are going to calculate r squared in a different little way. R squared equals 1 minus SSE over SST. Basically, my unexplained errors over the sum of the squares total. And we're taking it away from 1 because this will give us this unexplained amount. Just this value here gives us the unexplained. And remember when we were talking about it before, the r squared gives you the explained amount, how much is explained of the variation in y from the least squares regression line. So we need to take away from 1 to give us that proportion of what's left. Almost like thinking of 100% what's left. So if I go back to this on my Inspire calculator and I get the sum of the squares, it spits out 0.968, something around there. That's technically my y value, take away its predicted value, the residuals squared. And it means the same thing as my SSE. There's also, when you calculate two variable statistics, I believe it's two variable statistics, all the way at the bottom, gives you that whole list of all these variables. There's SSX and SSY. And when I click over SSY, because I wasn't really sure what that's standing for, it gave me this reason here. Y minus Y bar squared. That is my sum of my squares total. And it actually gives me a value of 1.881. So if I calculate this SSE over SST, I would get 1.968 over 1.881. And when I do 0.968 divided by 1.881, I get 0.51462. That should look kind of familiar because when I take away 1, I get 0.483538, which is about 48.8 45%. Remember we were talking about at the beginning. 45% of the variation in y can be explained by the least squares regression line. That means that the residuals really come into play when you're talking about this r squared. So technically you can get this r squared two different ways. You can just take r and square it, which is a much easier way. But also I wanted to show you how you get it from this unexplained values and the total values.